Welcome pre-calc class. In this video we will be simplifying trig expressions by using trig identities. You will probably need to have out your trig identity sheets. We will be using these throughout the entire lesson, so please go ahead and get out your trig identity sheets. If you've not done that yet, your heading for today is simplifying trig expressions by using trig identities. Simplifying trig expressions by using trig identities. Now we've already looked at the fundamental trig identities, and we also have learned how to solve trig functions by using trig identities, but today we're going to simplify trig expressions by using trig identities. Okay, please include today's date in your notes if you would, please. Include today's date, and the lesson number is 10.1. Alright, let's continue on. Let's jump right into this by starting off with some simplifying problems. Okay, now, before we get into this, the number one problem that students have is this. Every year they say to Mr. Earhart, Mr. Earhart, we don't know how far to take these problems. We don't know if we should stop after we've simplified down to one term or two terms or what we should do. And I understand that, and understand on a test or a quiz, I will be very reasonable, and I will usually tell you how far I want you to take a problem, or I will make the problems multiple choice. So if you've taken a problem and you've simplified it down decently far, and you look off to the right, and in the matching you don't see an answer over there that matches your problem, then you know you have to take it a little further. Okay, so please understand that as we get ready to do these problems, one of the main problems you're going to have is, well, Mr. Earhart, I thought we'd gone far enough with that problem. And understand, on tests and quizzes I will make it very clear as to how far you need to take these problems. Okay, so having said that, go ahead and copy down this first problem, and let's simplify this expression. Now, understand we have a big list of fundamental trig identities that we can use. And so when I look at this, one of the first things that jumps out at me, go ahead and copy this problem down if you've not done that yet. One of the first things that jumps out at me is cosine squared x. Now if you think about it, we have a trig identity that says sine squared plus cosine squared equals 1, correct? Sure. So if we take this sine squared and bring it over and make it a negative sine squared, you can do that. We now have a substitution for cosine squared. We can put 1 minus sine squared. So watch what I do. I'm going to go ahead and put sine x for this right here, and then parentheses, and I'm going to take this out right here, and instead I'm going to put 1 minus sine squared x, and then bring down my negative sine x. Okay, now again, students, there's no steps I can teach. I can't say do step 1, step 2, step 3, step 4, and you'll be fine. You just have to look at a problem, and these problems give students problems every year. Okay, and you're just going to have to learn to look at these problems and just kind of look at what looks like a common sense substitution and make it, and then simplify and see what happens. Okay, so we've made a substitution here for cosine squared. Now I can take this sine and distribute it through the parentheses. So sine times 1 is sine. Sine times sine squared here would be sine cubed. Okay, and then bring down your negative sine x. Okay, now look what we have. This would be equivalent, students, in an algebra statement, in an algebra class, to having x minus x cubed minus x. In other words, notice how this term and this term are like terms, so we can combine those. Well, it's the exact same thing here. We have 1 sine x and minus 1 sine x. So those two cancel out, and you're just left with negative sine cubed x, and that's it. That's as far as we can take this expression. So we have taken this original problem here, students, and we have simplified it all the way down to this. Okay, so that's what we're going to be doing today, is simplifying these expressions. All right, let's take a look at another problem, and if I'm going too fast, just have the supervising teacher pause the video. Okay, all right, here we go. Let's take a look at this problem here, and let's get some room here. All right, now the first thing we're going to do here, I'm looking at this and I'm saying to myself, wow, what can I do to simplify this? But I'm thinking, you know, for cotangent, now watch this, sine t. And again, students, you just have to take notes and learn to do this. For cotangent right here, I can put, if I can get my pen to work here, All right, here we go. For cotangent, I can put cosine over sine. Cosine over sine. Okay? And then for cosine, I can put cosine, just put it over 1. Now that's a step. And now look, I can multiply these two fractions together. So I have sine t plus, now, cosine times cosine is cosine squared. Sine t times 1 is sine t. Now let me pause, let you guys get caught up with me here. And you're probably thinking, Mr. Earhart, I would have never thought to make that first substitution right here. I understand that. And really it comes down to practice, practice, practice. And what's another word for practice, by the way? The dreaded homework word, okay? But it comes down to practice, 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 and just really getting experience on these problems, okay? Now, let's go ahead and put these two fractions together here, okay? So I'm going to put this over 1, all right? Now, I've got 1 for a denominator and sine for a denominator, and we know that when we're adding fractions, we have to have a common denominator. So, if I take this fraction here and I multiply the top and the bottom by sine, that will give me a common denominator. Well, Mr. Earhart, can you do that? Sure, guys. You can take any fraction and multiply it by anything without changing its value, as long as you multiply it times the top and the bottom. Like 2 over 2 would give you 2 over 4. So you didn't change 1/2. 1/2 is the same thing as 2/4. So I'm going to multiply the top and the bottom of this fraction here by sine. Well, sine times sine would give me sine squared, and sine times 1 would give me sine. Now remember, I did that so that I have a common denominator, okay? So, and actually, yeah, there we go, yeah. So now I have a common denominator. So I multiplied this fraction right here by sine over sine, which I can do. So now I have a common denominator. This is so cool. Watch what happens. You can add your two fractions together. So sine squared plus cosine squared is sine squared plus cosine squared all over what? Sine. Remember, when you're adding or subtracting fractions, you leave the denominator alone. And now, students, look at your trig identities. What is sine squared plus cosine squared? It's 1. So 1 over sine t. We're almost done, guys. What is 1 over sine t? Well, the reciprocal function, cosecant of t. Cosecant of t, okay? So this entire expression right here simplified all the way down to this right here. Now that's pretty cool, okay? So this is kind of the stuff we're going to be doing today, okay? All right, now let's try factoring some expressions. Factoring is a form of simplifying, so let's give this a try, okay? All right, let's factor these 3 expressions. Here we go. All right, let's take this one first here. Now, notice it's a binomial. We have 2 terms, 1, 2, and notice they're both perfect squares. I know the square root of secant squared, and I know the square root of 1, and there's a minus sign here, so we know how to factor this. This is easy. So the square root of secant squared is secant, and the square root of 1 is 1, so put a 1 here and a 1 here, make one positive, make one negative. Look at that. Done. All right? Pretty cool, correct? All right, let's go ahead and continue on. So, factoring expressions. Now, this one here is a little more challenging, okay? Now, be careful on this one here. Now, here's what I suggest to you that you do, okay? This is really difficult written like this, so I would like to suggest to you that you rewrite it like this. Now, you can do that. That's totally fine. For 4 tangent squared x, just put 4x squared. Take the tangent out. And then for tangent x, just put x and take the tangent out. And then bring down the negative 3. Now, you can do that as long as when you're all done factoring, you put the tangent back in again. It's that simple. And look, you don't have to take the tangent out if you don't want to. If you can factor it with it in there, then more power to you, okay? That's totally fine. But if you want, This makes it a little easier, and then in your final answer, just put the tangent back in. So we learned how to factor these the first week of school. So here we go. It's a trinomial with the lead coefficient of 4. So 4 times negative 3 is negative 12. We list out all the factors of negative 12, and the one I'm going to use is positive 4 and negative 3, because these two numbers here add up to my positive 1. So I bring down my first term, and I bring down my last term, and then right here in the middle, I put positive 4x, negative 3x. Now, I warned you guys during the first week of school that I was not going to reteach factoring, okay? So I'm going to keep moving, okay? All right, pull out what's common in the first two terms, 4x, and you're left with x plus 1. Pull out what's common here, negative 3, and you're left with x plus 1. Now, write your matching parentheses once. And if I'm going too fast, students, just have the teacher pause the video, okay? I'd rather go too fast than too slow, okay? You can always pause the video, but you can't speed it up, so that's fine. There. Now just put tangent back in. So your final answer would be tangent x plus 1, and then 4 tangent x minus 3. Remember, everywhere there was an x, you took a tangent out, okay? And so we put it back in. And there we go. Not too difficult, okay? All right, now let's factor this last expression here. And look guys, we have perfect cubes. We have a binomial, two-termer. We know the cubed root of sine cube. We know the cubed root of 8. We have a perfect cube. So just put a little parentheses, then put a big parentheses, and here we go. The cubed, and by the way, if you want to take the sign out and just put x cubed minus 8, and then when you're all done factoring, put the sign back in, that's fine. I don't feel like it's necessary for this kind of problem here. This kind of problem here is pretty simple, okay, in my opinion, but that's up to you. So the cubed root of sine cubed is sine, so I put a sine x, and the cubed root of 8 is 2. Remember how to do this? You bring the sign down, you put it here. Now, whatever you have here, you multiply it by itself. So sine times sine is sine squared, and you put that right here. Then whatever you have here, you multiply it by itself, so 2 times 2 is 4. And that goes down here at the end. Then you multiply these two together, so sine times 2 is 2 sine x. And then, remember, whatever the sign here is, you always put the opposite here, okay? And this sign here is always positive, always. And this one here is always positive. And then whatever this sign here is, you always put the opposite here, okay? So there we go. Not too bad. We're just factoring trigonometric expressions, okay? All right. Hard word to say there. Moving on. All right. Now let's take a look at one more, just one more, and see if we can't. Okay, let's not do that. Let's take a look at one more here. It's a little more difficult. And let's see if we can't help you with this, okay? Now, when you go to factor this last problem here, look, you've got a cosecant and a cotangent. That's really weird. That's going to be difficult. In fact, it's going to be impossible to factor unless there's like a cosecant in every term you could pull out, or a cotangent in every term you could pull out. And we don't have that. So we've got to think of a substitution that we can make, okay? Well, if you look at your Pythagorean identities, I'm looking here that cosecant squared equals 1 plus cotangent. So for this, I can put 1 plus cotangent squared and then bring down the rest of the problem. And look at this. I've got all cotangents. I can factor this. Put your cotangent x first, squared x first, then your negative cotangent x, and then combine your like terms. 1 and negative 3 is negative 2. And now rewrite this like I taught you to. Drop your cotangents and put x squared minus x minus 2. Oh my, this is an easy factoring problem, students. This is the kind where the lead coefficient is 1. So you simply say to yourself, what two numbers would multiply together give me negative 2 and add together give me negative 1? Your middle term. Well, that's easy. Wouldn't that be a negative 2 and a positive 1? When you multiply them, you get a negative 2. When you combine them, you get negative 1. Sure, it would be. So x minus 2, x plus 1. Look at that. And then go ahead and put the cotangent back in. So your final answer would be cotangent x minus 2, cotangent x plus 1. Look at that. All right. and we factored it. Okay, moving on. What if I asked you to simplify a trig expression by adding them together? Well, we should be able to do this, students. Come on, look. First of all, I have to have a common denominator. So if I take this denominator here, if I take this fraction here, excuse me, and multiply this fraction by sine over sine, I get, now look at this, I get sine squared x, and then do not multiply the denominator, just write them side by side, trust me, okay? There we go. So I multiplied this first fraction by sine over sine. Now, multiply this fraction here by 1 plus cosine x. Mr. Earhart, why are you doing that? Because look what my denominator will become. I'll have a common denominator, guys. Look, I took this denominator here, right here, and put it over itself and multiplied it by this fraction. Then I took this denominator here, put it over itself, and multiplied it by this fraction. Okay? So here we go. Now, cosine multiplied through cosine times 1 would be cosine, and cosine times cosine would be cosine squared. And now leave your denominator, sine 1 plus cosine x. Now, students, you really need to be able to do this. So if you're struggling with this, then you really need to watch this part of the video over and over again till you understand what I've done here. I now have a common denominator. Look, it's the same. Alright, well, there should be an x right here. There we go, sine x. That's not very neat, is it? Let's see if we can fix that real quick. But other than my copying mistake right here, we have a common denominator. Okay, there we go. Now, when you have a common denominator, put your two fractions together. Okay, so sine squared plus, and then look, students, learn to think ahead. You are more than welcome to put plus cosine x plus cosine squared. But think about it. Doesn't it make sense that we probably want to put the sine squared and the cosine squared side by side? So sine squared x plus cosine squared x plus cosine x. It makes sense to me because of the Pythagorean identities. We're gonna make a substitution in a second for these two terms, okay? Because after you combine the two expressions, you definitely want to simplify as far as you can, okay? Now here's your common denominator, sine 1 plus cosine x. Now, students, again, if I'm going too fast, just have the teacher pause the video. Now, look at this. I have sine squared plus cosine squared. Well, that equals 1. So I'm going to lift that out of there, and I'm going to put a 1 in there. 1 plus cosine, all right? So I have 1 plus cosine x. Look at this. Over sine 1 plus cosine x. These will cancel. So now I'm left with 1 over sine. I keep forgetting my x. There we go. And students, 1 over sine is the same thing as, remember, reciprocal functions. 1 over sine is the same thing as cosecant x. There. This whole entire expression here simplified down to that. Really cool. Okay? Alright. Now, one more problem and we're finished. This is it. Last problem, okay? How about rewriting a fraction so that it's not a fraction? Wow. Now, that's not going to be easy to do, okay? So, here's what I recommend that you do. I recommend that you do this. Think about what could you multiply this entire fraction by so that you get something in the denominator that we can work with. And of course, right away I'm thinking, well, I mean, if I multiply the top and the bottom by the conjugate, and the conjugate means you change this middle sign right here, you would get 1 minus sine x. Now, if I multiply the top and the bottom by this, it might work and it might not. Let's give it a shot, okay? So 1 times anything is just itself 1 minus sine x. Mr. Aaron, I have no idea where you got this. I'm just brainstorming, guys. I'm just trying to think, if I multiply the top and the bottom by the conjugate, I mean, middle terms are going to drop out. I mean, watch. 1 plus sine times 1 minus sine gives you this. Remember, you take the 1 here and multiply it through, take the sine and multiply it through. You end up getting this. 1 plus sine minus sine, and then minus sine squared. And I knew that was going to happen. And look, your positive sine x and your negative sine x cancel out. Okay? So, I'm just trying to show you why I did this. I did all of that so I end up with this in the denominator. 1 minus sine squared x. Now, how does that help, Mr. Earhart? Well, look, guys, we have a trig identity, Pythagorean, sine squared plus cosine squared equals 1. So if I bring the sine over and make it negative like this, look what look what 1 minus sine squared x equals. It equals cosine squared. So for this whole denominator right here, did not mean to do that. For this whole denominator here, 1 minus sine squared x, I can put cosine squared. Cosine squared. Oh, Mr. Earhart, I hate to break the bad news to you, but you still got a fraction. I know that, but watch. Because I have one term in the denominator here, I can split this fraction up. Watch. 1 over, see if this makes sense. 1 over cosine squared minus sine over cosine squared. Okay, that should make sense. Now, let me show you real quick, students, what I did here. If you were to take these two fractions and go back, excuse me, and go backwards here and subtract them, look, you have a common denominator. You would get this, 1 minus sine x. So we just took a fraction and went backwards. And now you say, well, Mr. Earhart, 1 over cosine squared. Okay, think reciprocal. Think reciprocal function. The reciprocal of cosine squared is secant. Or excuse me, the reciprocal of cosine is secant. Well, if it's cosine squared, then the reciprocal of cosine squared would be secant squared. There we go. So 1 over cosine squared is the same thing as secant squared. Minus. Now, look at this fraction here. Try this. Think about this. I'm going to put sine x. I'm giving you guys so much to think about, but watch this. Sine x over cosine x times 1 over cosine x. Now, did I change anything? No. If you take sine over cosine times 1 over cosine, sine times 1 is sine. Look, cosine times cosine is cosine squared. Why would I do that? Because look what I can do now. I'm finished. Watch. Look. Remember, my goal was to have no fractions. Well, look. Sine over cosine is, look at your trig identities, tangent. Times 1 over cosine is secant. There we go. Okay, now we might be able to take this a little further. I'm looking here at secant squared would be 1 plus tangent, but this is good enough here, okay? So we did it. We accomplished our goal. We started off with a fraction, and we said, can we rewrite it so it's not a fraction? And we did, okay? I know this is not the easiest stuff in the world. It's easy to understand as I explain it to you, but it's not easy to think of this on your own. And it's just going to take practice, students, okay? A lot of practice, all right? Okay, contact me if you have any questions. I hope this video has been a help to you.